The Russ Prize is the premier prize in bioengineering. It was originally awarded in the year 2001 and is awarded every other year. It's awarded by the National Academy of Engineering in cooperation with Ohio University. Fritz was one of the original entrepreneurs after World War II in the electronics industry. He and his wife Dolores formed their company in the early 1950s. They dug the foundation for their original building themselves. When they sold the company in 1987, it was one of the largest engineering consulting firms in the country. They lived modestly, even though they were very wealthy people at the end of their lives. They started the award because Fritz was always concerned that the Nobel Prize was not awarded in engineering. He conceived the Russ Prize to fill that gap. The type of person that would win the Russ Prize is someone who would take a basic scientific concept, apply engineering principles, and solve a practical problem. That practical problem, in the case of the Russ Prize, would have significant impact, be in widespread use, and improve the human condition. Fritz was known for thinking 20 or 30 years into the future. In fact, I would say that his impact on Ohio University itself is to inspire us and to set the example for long-term visionary thinking. Examples of past winners of the Russ Prize have included the inventors of the implantable heart pacemaker, the inventor of kidney dialysis, the inventor of the automated DNA sequencer, and the inventor of the enabling technology for heart-lung machines. The Russes wanted to ensure in perpetuity that achievements such as these continued to be awarded, and thereby inspiring a new generation of engineers.
The 2017 Fritz J. and Dolores H. Russ Prize is awarded to James Fujimoto, Adolf Furcher, Christoph Hitzenberger, David Wong, and Eric Swanson for their invention and development of optical coherence tomography, or OCT. OCT has become an established medical imaging technique in ophthalmology and cardiology, improving diagnosis and treatment of disease, as well as advancing understanding of disease mechanisms in multiple fields. OCT uses light to perform high-speed micrometer resolution three-dimensional imaging of tissue microstructure, enabling clinicians to visualize pathologies within the body in real time. James Fujimoto, professor at the Massachusetts Institute of Technology, played a pioneering role in the invention and development of OCT. His group's paper, Optical Coherence Tomography, published in Science in 1991, remains one of the most cited papers in biomedical optics. He was a co-founder of the world's first two OCT companies, which translated OCT technology to ophthalmology and to cardiology. Adolf Furcher, Professor Emeritus at the Medical University of Vienna, is a pioneer in ophthalmic interferometry. His group demonstrated the first measurement of human axial eye length using low-coherence interferometry, which is used extensively during cataract removal, one of the world's most common surgical procedures. Dr. Furcher's group also demonstrated early concepts in spectral interferometry, which led to powerful advances in OCT imaging speeds. Christoph Hitzenberger is a vice chair of the Center for Medical Physics and Biomedical Engineering at the Medical University of Vienna. Working with Dr. Furcher, he pioneered the development of low-coherence interferometry, an intraocular distance measurement. Dr. Hitzenberger's group has made advances in ophthalmic OCT technology and applications, including Doppler and polarization-sensitive OCT, which enables structural and functional imaging. David Wong, MD, PhD, and professor at the Oregon Health and Science University, is one of the pioneers of OCT. While at MIT, he demonstrated the concept of representing one-dimensional axial scans as two-dimensional images, enabling cross-sectional views of the eye. His 1991 science publication on OCT has been cited over 6,000 times. Eric Swanson co-developed and demonstrated early concepts in low-coherence and swept-source OCT, and co-designed the first clinical OCT instrument, which enabled studies in ophthalmology patients. He has played an important role in OCT's translation, including co-founding of the world's first 2 OCT companies, which translated OCT technology to ophthalmology and cardiology. OCT has revolutionized the practice of ophthalmology, has proven to be a powerful tool in intravascular imaging, and has the potential to impact many other clinical specialties. It has facilitated diagnosis and treatment of millions of patients around the world. It is a testament to the power of engineering and its potential to advance clinical medicine and world health. OCT was made possible by the groundbreaking work of James Fujimoto, Adolf Furcher, Christoph Hitzenberger, David Huang, and Eric Swanson. And for this, the NAE awards these pioneers with the 2017 Fritz J. and Dolores H. Russ Prize.